Well, welcome, everybody. Before I begin, there is tea, iced tea, and coffee, and some cookies back there. Please help yourself at any time during the program. I'm Gloria Stultz. I'm the chair of the Historical Society Board. Other board members that are here today are Larry Linscott. Very glad to see Larry. Rita Bruner. Rita? All right. Burl McCullough. Of course, Carol McNew. She's our secretary, and Pat Nelson is our treasurer. Well, that's a nice compliment, that you never get old. And Sandra Hammerl. Thank you. All right, we have a little bit of business to attend to before we start our program today. The Historical Society is a very active board. We are friends with lots of other, some of the other historical organizations, and the Florence Archives is one of those. So we heard at our board meeting this last week that they were having a little bit of a tough time, as all of our nonprofits do from time to time. And so we were able to help them out of their little fix that they're in. Rita is being coaxed to come up here and receive a check for $2,000 from the Historical Society as a gift to help them through this tough time. Rita, come up and say hi. So Rita is on our board, and she's on the Florence Archive board. So we are appreciative of the work that you guys do, and in Florence, you are a lead organization for the historical endeavors there, and we're glad to help out.
Thank you for this. Thank you very much.
So this gift will be used to continue the important progress they've made on the collections they have in their files and their archival boxes. We'll be close to them during this next year and see how they're doing. They have some money-making ideas going for them, and we hope that they have success with their new membership drive in the coming months. Many of these folks here today would be interested in joining your efforts, perhaps. So, if you, as you sit here, aren't a member of the Historical Society, for us, we certainly encourage that. Individuals, $15 a year. Families are $20, groups at $25, and a lifetime membership for the Fremont County Historical Society is $150, one time. Yeah. So Pat is at our book table, and she has envelopes and can help you do the membership if you would like to do that before you leave today. So that ends our business meeting, I guess, Carol? Business is closed. No more business talk. Today our speaker is Larry Green. Larry's a very prominent and successful historical archivist in his own right, keeping up with the railroad history of this county. Larry's bio is in the newsletter. There's extra copies out on the book table if you'd like to read that. And if you would like to, if you would like to have a copy, there are extra copies on the book table. Getting a little redundant here. Without further ado, may we present Larry Green.
It's nice to see so many people turn out here. I always feel so welcome when I come to Canyon City. And I spend more time down here than you can imagine. A couple of things to share with you before I start. One of my passions, I guess you would say, is researching history of the Royal Gorge War, and of course the Hanging Bridge is a component part of that. I'm always focused on the idea that I would like to break a lot of the myths and misconceptions that for over 140 years have been tied to this event. And I think today you'll find that there are some interesting aspects that you weren't aware of before. The image on the screen was done by Charles Savage. And if you're not familiar with him, in 1874 he visited Canyon City and coined the phrase Royal Gorge. This image was taken in the spring of 1881. He was contracted with the Denver and Rio Grande Railroad to shoot images along the rail line for advertisement purposes. He's probably most famous, though, for the work that he did. He was from Salt Lake City, Utah, by the way. His most famous work are the images of the driving of the last spike at Promontory in Utah in 1869. For many years, he was uncredited for those, but it's become more and more apparent that he was responsible for the best taken that day. This is part really of an expanded presentation that I did for the Santa Fe Historical and Modeling Society annual convention a couple of years ago. And I've also done it for the Pueblo Archaeological and Historic Society, but I've added quite a bit more for you today. A little geographical background. Well, first of all, I do things backwards. This is a list of the image contributors that helped make this program possible today. The gentlemen on the left-hand side, of course, all are long deceased. The most important person up there is Joseph Collier. He's my favorite photographer of the time. And you'll notice on the right-hand side at the bottom, more current and still alive individuals. Robert Schaefer, Craig Trout, Grant Collier, the grandson of Joseph Collier, Eve, and if I'll mispronounce her name, Nagati. Thank you, Eve. I just call her Eve, it's a lot safer. And myself. The Arkansas River has its headwaters in the basins and upper part of the Arkansas Valley, surrounded by the Saguache and Mosquito Range. And as it makes its way east, it passes through a series of parks and canyons. I put the list up there that I know because I like the antique names, and I'm afraid they're all disappearing. Hayden Park, Granite Canyon, Princeton Canyon, Shipka Pass, I bet you haven't heard of. Cottonwood Park, Buena Vista, Browns Canyon, Sand Park, Salida, Red Hill Park, Pleasant Valley, Texas Creek Canyon, Spike Park, and Webster Park, or Parkdale. Actually, it's Lower Webster Park, I understand. This is what the Arkansas looks like when it has water in it. When it gets to Parkdale, it enters the biggest canyon that it passes through. Geographically, it is known as the Grand Canyon of the Arkansas, not the Royal Gorge, the Grand Canyon of the Arkansas. It's about 8 miles long. It passes through a series of natural faults. Within the Grand Canyon of the Arkansas is a legally defined section about 1.2 miles long called the Royal Gorge. It actually has a federal legal description. It is derived from the 1875 Pacific Railroad Act, in which railroads were required to share narrow defiles or high mountain passes, which the section between the east side, well, it's about halfway between the Hanging Bridge on one side and on the other side. So it does have a legal description, but everybody calls the whole thing the Royal Gorge, so we'll just stick with it for now. An overhead view looking straight down. We're going to look at a section that's about 300 feet long. On the east side, or downstream side, is what everyone called Telegraph Gulch, but I understand now everybody's pushing to use it as Pike's Gulch because apparently he climbed up out of the canyon at that location. And on the west end is the crevasse or Bigler's Gulch, which we'll take a look at here. In between the high point, which is about 500 feet above river level, is called Lion's Leap. And this is Lion's Leap looking from the ground up. This is one of our research days. Lovely, lovely climate we work in. This is early January, 25 degrees air temperature, 20-mile-an-hour winds, and any kind of equipment that you can imagine. Here's what Telegraph Gulch looked like before the fire with the funicular railroad that was there. That, of course, was the easiest way to get to the hanging bridge. Of course, now it's not possible to do that. This is Bigler's Gulch on the west side. It is actually a natural fault line that runs through the area. And this is what that section looked like in 1879. At that time, it was possible to get into the east end of the canyon and to the west end of the canyon, but you couldn't pass through because of this rock formation in the middle. There was one time of the year the passage was possible. That was in the winter. You could walk across the ice if you were brave. And this is an image that Eve put together that I'm sharing with you. You can see the two comparison points of where the rail line is today and where the rock was in the past. In the winter of 1878, a number of individuals made their way into the gorge to take a look at it. We know that one of them was A.E. Robinson, the chief engineer of the Santa Fe Railroad. Another one of the gentlemen was C. Shaler Smith, a very noted bridge designer and contractor at the times. We believe Chalmers Talbot also accompanied them and took stereo photographs of the trip. This is A.A. himself. He was the chief engineer of the Canyon City and San Juan Railroad, the Pueblo and Arkansas Valley Railroad, Natchez and Topeka and Santa Fe. Eventually, he became president of the railroad. He was a civil engineer by trade, very, very skilled, probably one of the best railroad engineers of the 1880s. With him was Smith. Smith is a kind of an interesting character. He was born in Pittsburgh, Pennsylvania. He didn't live to be a very old man. He died in 1886. I think he was 50 years old. And it's probably because of that we don't know as much about him as we should. During the Civil War, he served in the Confederate Army and was responsible for building the largest powder works in the Confederacy at Augusta, Georgia. And I guess today we'd probably throw that picture out because we wouldn't want to recognize what his contributions were. Anyway, the idea for a rafter bridge came from A.A. Robinson. Instead of the overhead bridge supports running parallel to the bridge, he suggested that the bridge supports run transversely across the canyon. Now, rafter bridges are not really that unusual. In Europe, there are many of them. But in the United States, this seems to be the only and most important one. Smith took Robinson's ideas, returned to his office in St. Louis, where he worked up the plans for a rafter bridge. They were submitted to Robinson, who enthusiastically accepted the plans and offered what is known as a turnkey contract for the bridge. A turnkey contract includes fabrication, delivery of the materials, erection of the bridge, includes the labor to put it together, and the inspection when the bridge is done to be turned over to the company. Now, one might ask, why didn't the Santa Fe engineers work on this bridge? And the answer is really quite simple. This is the first iron bridge ever built on the Santa Fe Railroad. None of the very, very qualified men that Robinson had working for him had any experience working with iron. All the bridges between Topeka, Kansas and Pueblo, Colorado were all wooden trestles. So they went to an expert. This is an example of Smith's work on the right-hand side. He designed some spectacular bridges. And there are a couple locally you can still go see. The Spider Bridge on Glorieta Pass is a long walk to get to. But the Cascade and Lobato trestles on the Cumberus and Toltec are easy to go see. And he was responsible for them. Smith also designed bridges in Australia and Peru. So He's better known than we know him, I guess is what it comes down to. Before you can build a bridge, you have to have grading. You have to have a way to get to the bridge site. On September 19, 1878, A. Robinson issued the following contracts for grading. They basically start in Canyon City on the east side of town, about where Walgreens is located today, and extended all the way to 118, which is just outside of Leadville. You'll notice that there are a couple places where the contracts weren't issued or amounts weren't listed. Mileposts 3 and 4 was land owned by the Denver and Rio Grande and was in the midst of condemnation. And 101 through 113, a number of small individuals held contracts spread across it. You'll notice that mileposts 5 through 12, which includes the Royal Gorge and the Hanging Bridge site, were contracted Lippy and Fox. They were two Chicagoans. And I have no idea how they ended up in Colorado, but they had the winning bid, $205,952.28. And in today's money, almost $6 million. One other individual we ought to mention up there is Sam A. Hutchins. Sam Hutchins was a contractor for the Denver and Rio Grande, and when the Santa Fe leased the Rio Grande, all of the Rio Grande contractors were thrown out of work. And so the Santa Fe tried to offer them substitute work, trying to take kind of the sting out of the lease. Sam Hutchins was the individual who brought a steam drill to the Royal Gorge to try it out. But apparently it never was very successful because we only have 1 or 2 pictures of it, and then it disappears from the scene. This is a horrible picture, but is a one of a kind. This is a Dana B. Chase image, and it shows graders actually working in the Royal Gorge. There's 4 or 5 men down here at the bottom. I don't know if this will work or not. Yeah, right down in here. They're working on a wooden plankway using wheelbarrows, and they're working on the grade. This is just west of the old gorge siding. Grading pictures of grading crews, especially in the mountains, are very, very unusual. We know that track laying reached the bridge site in late March, early April 1879. And when they got to the site of where the hanging bridge would go, they actually installed a temporary wooden trestle. And typical to Santa Fe standards, it had bents every 14 feet, large timbers across the top. It was designed and built so that it could be, the iron bridge could be inserted in between it without taking it out. And it also could be used as scaffolding while the iron bridge was being installed. You'll notice that they've gotten a walkway across the river installed, and that will be much more substantial as time goes on. A little bit later on, they've installed a gallows head frame kind of crane that they can use to lift things up and move them across the river. They've also put much more substantial timber in on the walkways to go across. This allowed the engineers to get in and get extremely accurate measurements for the various pieces of the bridge that they were fabricating. And it also gave them the opportunity to prepare the pad sites where the bridge foundations would sit. One thing I should mention to you, and I should have mentioned earlier, is that we look at these pictures and they don't match what the railroad looks like today. Since the railroad was completed through the gorge, the Rio Grande probably has rebuilt the line 4 or 5 times. And many of the curves have been shortened, and many of the tangent lines, the straight lines, have been lengthened. So a lot more rock has been removed than what appears at this time. This basically, if you look at it, is just a shelf that they've blasted out. This is looking downstream, gives you a little bit better idea. You'll notice on the left-hand side at the bottom, there's a small masonry wall that sticks out. This was put in to divert the river away from the bridge abutments. On June 16, 1879, the Santa Fe track crews reached this site, famously known as DeReamer's Fort, more accurately known as Fort Ryan. It was named after a Rio Grande, not superintendent, a foreman. who was in charge of the site. This photograph, by the way, is staged. It wasn't taken the day that this occurred. I guess common sense being smarter than a gun, the Santa Fe crews decided to back off and allow the courts to decide what would happen. And about a week later, Judge Moses Hallett, the federal judge in Denver in charge of the Royal Gorge War cases, halted all construction on the line from Canyon City all the way to Leadville. There's cease and desist orders, so both groups kind of backed off. This is what that site looks like today. It's a lovely little 7-mile walk. On July 15, 1879, attorneys for the Santa Fe Railroad approached Judge Hallett asking for permission to install the hanging bridge. They did this as a measure of what they called equity. And that was, if the bridge washed out, the wooden trestle washed out, it would reduce the value of the completed line, which at that time was in contention. Judge Hallett was in the process of trying to determine what the value of the work done by the Santa Fe was and how much the Rio Grande was going to be forced to pay for it. Eventually, they're going to pay $1.4 million. We too loud for you, Charles?
What?
We too loud for you?
I'm sorry.
Okay. Hallett did give permission for the installation of the hanging bridge. The only problem was the bridge wasn't in Colorado. C. Shaler Smith had contracted with the Edgemoor Bridge Company, Ironworks, in Edgemoor, Delaware, to fabricate the bridge. And it just so happened that he was also a consultant to the Edgemoor Company. The Edgemoor Company is a pretty big outfit. They were responsible for building the decks for the Brooklyn Bridge. They also built the iron viaduct section for the famous Eads Bridge in St. Louis, Missouri. We do know that on January 23, 1879, the bridge pieces showed up in Pueblo. We don't know exactly how they got from Edgemoor, Delaware, to Topeka, Kansas, but we do know that it was transported west across the Santa Fe. And it arrived in what they believe were 11 standard gauge carloads. Mark Hemphill, who's the former editor of Trains Magazine and formerly with HDR Engineering and currently with Rio Grande Pacific Company, calculated out the loads for me, how much space it would take to haul all this bridge west. We believe that the transfer between the standard gauge and the narrow gauge took place at the transfer tables in Pueblo. And at that time, if you're familiar with Pueblo, this is where Pueblo Union Depot sits. So the transfer tables were out in what is the passenger train yard of PUD now. We're not exactly sure how many carloads of narrow gauge equipment it took, but that was one of the factors that C. Shaler Smith had to take into account. The railroad between between Pueblo and Canyon City was narrow gauge. The bridges were listed at 30,000 pounds capacity, which also matched the cars. So the biggest piece you could transport on the narrow gauge was 15 tons. We know that the bridge made its way west. We don't know how many cars it took. It ended up at the materials yard here in Canyon City. Materials yard on the railroad is their version of Lowe's. Anything that you can think of that you need to build a railroad is stored at the materials yard and can be readily loaded on cars and forwarded to the front. I know that at the materials yard in Canyon City, the materials for a depot at what is today Salida were available, and a depot for what they call Cottonwood Buena Vista were available, tongue-tied, and materials for depot at Leadville were on hand. Windows, door sashes, doorknobs, hinges, nails, paint, tar paper, anything you can think of was all there. Anyway, when the bridge got to Canyon City, we were fairly sure that the large pieces were left on flat cars because it didn't make sense unloading them. But the smaller pieces probably were sorted out, laid on the ground, and prepped for delivery to the bridge site. At the bridge site itself, The track, which had to be kept into service because basically the Santa Fe wanted to make sure they had a continuous piece of track that they could claim when they were going to sell it, was jacked up on timbers to allow for more space for the bridge to be inserted underneath it. And you can see the H-frame crane that they've erected on the one side, which they moved from one of the underneath each of the overhead rafter systems that could be moved from one to the other and used to jack up pieces. This is another view of the same site taken from the east. And you can see some fairly significant timbers have been put in place across the river. If you're unfamiliar, in locations, it's anywhere from 30 to 40 feet across here. Those are big pieces of lumber. The first part of the bridge to be installed were the pedestal pads. They basically are steel iron plates. I'll correct myself because this is an iron bridge. The iron plates were placed against the rock wall, holes were drilled, bolts were inserted into the holes, and then hot lead was poured into the hole to solidify the bolts so it could never be pulled out. And then the plates were established and secured with double nuts. The connection between the rafter beam is a large steel pin, large iron pin. Slap myself. This kind of bridge is very common. They were built in the United States, these kinds of connections. And C. Shaler Smith actually had a patent on these. So he had a lot of parts that we don't really know about. The riverside, and I refer to it as the riverside and the rock side instead of north and south because I get myself confused. The riverside rafters are all different dimensions. None of them are the same size. The rock side rafters, which I've never been able to get to measure, are, I believe, all the same size. And as you can see, they range from 60 feet long to 71 feet 8 inches. They tend to be so long that they twist if they aren't supported. And you can see that the rafters are interconnected by a series of braces that run on a diagonal across. In order to strengthen the rafters on the riverside, there are a series of truss rods that run along the bottom of the rafters to provide tension. And from what we understand, these were laying flat down on the ground and they were lifted up by the gantry crane that they'd built, the wooden gantry crane. They probably were supported with cribbing. The whole rafter system is like an arch. The last pieces at the very top are what hold it in place and provide the steadiness so that it doesn't move. So there was a lot of metal hanging in the air before they got it all tied together. The very top of the rafter system is exceedingly unique. If you look carefully up here, you can see that at the top we have a metal piece that goes up and loops over one of the iron pins and then comes down and it is connected to the cross member with another set of iron pins, which is connected to the links that drop down to the deck to support the bridge. And you have all this stuff hanging in the air until you get all these pins in. So 1, 2, 3, 4 pins have to be in place. These are massive pins. They're over 5 inches in diameter. You'll also notice a few places where these X-braces that go across have been hit by falling rock and they've been dented. In some places, they've actually been knocked off. This is a cross-section of what one of the beams look like. You could go to a local metal store, metal supplier, and buy all the pieces to build this bridge. The hard parts to come by would be the 7 feet high, 30 feet long, 3/8 of an inch steel plate that make up the big girders. But everything else is very common. The top is a 16-inch steel plate, a 1/2 inch thick. The sides are 15 inches by a 1/2 inch. The only difference is the bottom of the rafter beams are open. This allows the water and everything to come out of the bottom so that you don't have a rust issue. The bottom also is a series of lattices that go back and forth. Lattice beams are not that unusual. Most bridges before 1920 used a lattice. The bridge itself actually sets on iron cylinders. And the iron cylinders are still there. You just have to know where to look to see them. And these big cylinders, there's one under the west abutment. There's another one here. There are two more on the short span on the other side. So the first thing set in place before the beam was put up were the installation of the iron cylinders. They sat on bedrock on the bottom. Today they're filled with concrete, but I think originally they were left open, which seems rather strange. This is what one of the cylinders looks like. Sitting on top here is a thrust washer, thrust bearing. It's two steel plates that are allowed to slide on each other so that you can have expansion and contraction. And this is another one of the thrust bearings. This one has grooves cut in it. I guess it's kind of to hold it in place. This is the one at the south end of the short or the rock girder. This series of pictures is some of my favorites because Joseph Collier shot them. This is a picture taken while the bridge was being built. The bridge is actually three bridges. Three separate bridges which are connected underneath of the sets of rafters. This gentleman is sitting on the very east end of the bridge. You can see that part of the rivets are missing. They haven't been put in yet. These are iron drifts that are used to hold it in place until they can get the riveter in there. If you're not familiar with riveting, a rivet is placed in a furnace and heated up till it's red hot. It looks like a stove bolt with no threads on that one end. It's stuck into the hole, and one guy on one side holds a metal piece to hold it in place. It's usually shaped like a hub. And the guy on the other side has a hammer, and he's whacking away on this red hot metal until he rounds it out and seals it tough. Bridge engineers will tell you that rivets work as well as nuts and bolts, maybe even better. In the distance, you can see this device, which is called a traveler. And it's basically just a box frame. And on the top of it is a trolley system with winches. A railroad car will be brought in with a piece of the bridge on it. They'll reach down with these large ropes that you can see dangling down right here, latch onto the piece of iron, lift it up into the air. They can move it lengthwise and sideways to get it in position. Then they'll drop it down, and then they'll rivet the two pieces together that they've got. Eve loves this picture. And I think she's correct. We believe that the gentleman straddling the rail here is C. Shaler Smith. Must have been a special occasion because we have ladies and kids on the bridge, which you probably otherwise would not have had. And again, you can see some of the apparatus hanging down that's used to lift the iron girders up. This is another one of my most favorite pictures. This is probably the one I like the best. You may be aware that during the Royal Gorge War, the Santa Fe Railroad bought 5 narrow gauge locomotives. 4 of them were patterned after what the Rio Grande had bought. They're 280s. And 1 locomotive they bought from the Profile and Franconia Notch Railroad. It was a little tiny locomotive numbered number 1 and called the Echo. I would assume that most of you have seen pictures of it. I didn't bring one today, but they're fairly common. These locomotives were very rare, and pictures of them are even rarer. This is probably the only one that I have ever been able to find. I understand there's one more, but it is not taken on any of the Royal Gorge. It was taken when these locomotives were leased to the Denver South Park and Pacific. This is locomotive 304. After the Royal Gorge War, this locomotive was converted into standard gauge, and it only operated for, maybe 10 years. It was so tiny that it didn't work anywhere for them. You can see the road number on the back of the locomotive right here. What's more interesting to me is what's behind on the locomotive. That's a piece of the bridge being brought in to be installed. And we have a close-up. everybody wanted their picture taken. Even the engineer's got his head stuck out the window. If you look at, on this section right here, this unusual, it's actually a C channel with a bunch of rivet holes in it. That's the connection between each of the plates of the bridge. Each bridge is made up of 3 plates, 3 pieces, and they're all connected together to create a 90-foot span, or about 90 feet. This is another close-up of that image. I found this one unusual because the suspension rods that come down from the cross sections at the top of the rafters have been pulled back out of the way so that the bridge installers who are putting these through plate girders in don't have to fight around them to get it in. They'll be lowered back down and then moved around and connected after they get the bridges riveted together. And another picture that shows part of the bridge being inserted. You can see our traveler box frame. From what I can see in that picture, they're still working on the 3rd part of the first bridge. Finding plans of the hanging bridge is like finding hen's teeth. When the Rio Grande and Southern Pacific merged, the plan stayed in Denver, but when the Union Pacific bought Southern Pacific, all of the Rio Grande plans went to Omaha. So you call Omaha and you ask the museum there, do you have the plans to the Royal Gorge Bridge, to the hanging bridge? And their answer, oh no, we sent them to the museum in Greeley. And my response is, there is no museum in Greeley. So you contact the people in Golden, where the Colorado Railroad Museum is, we don't know where they're at, sadly. This set of plans came out of the American Society of Engineers drawings, and I will tell you that were not as complete as they are now because I've added to them. I've put a lot of the details into the bridge. The red circles are the location of the iron cylinders. The east section of the bridge, and you have to give a little bit of fudge room because it's very difficult to get your hand into some of the spaces so that you can get an accurate measurement. But it measures about 93 feet 3 inches. It is a side hill bridge. The river side of the bridge is a truss girder, a through plate girder. But the rock side of the bridge sets on a rock ledge. So I guess you'd call it kind of a half bridge. The center section of the bridge is 91 foot 8 on the outside, but on the rock side, it is shorter because this section of bridge sticks back in past. So you have this side hill bridge and a little tiny chunk of a regular bridge on the other end. And this line that wanders around in here is where the water can get to, or could get to, in the past. The west section of the bridge is a little bit shorter. On the river side, it's only 89 foot 1 inches long. But on the rock side, and it's a true bridge, it is 99 feet long. So you have this kind of an offset bridge, which is really screwy. But apparently they built the bridge to fit the site instead of building the site to fit the bridge. In order to anchor the bridge to the rock wall, they used a series of bridge beams that are non-weight bearing. And basically, they're just a piece of iron that runs underneath. It's connected to the through plate girder out here in the air, and it runs over to the rock, and then there's a big iron pin drilled into the rock wall, driven in and leaded in so it can't come out. And this basically is the spacer that holds the bridge relatively straight. I don't think the bridge was ever purely straight, even when it was built. It just had little wiggles in it all the way down. This is the top of that connection, that little triangular piece right there. We can also see the intricate design of how the hangers coming down are connected through the 2 bridges. If you look right here, you can see the gap between the east bridge and the center bridge. And you can see these are stacked plates that have been riveted on together. And then we have the bolt that goes through to the other side. There's a companion piece on the other side. We also have stacked plates up on top, and then another set of connections up there. These, by the way, it's 6 feet from here to here. And these are not to scale, but basically how these girders were put together. The big part of the girder here is 7 feet top to bottom, and they average a little over 30 feet long. That's one iron plate. That was a pretty marvelous accomplishment if you think about it in 1881 to roll a plate that big. Today you could go to a metal supply store. You might stretch to have to buy that, but you can buy it. Vestas Wind Products down in Pueblo has train loads of this stuff come through every day to go out to build their towers. The top and the bottom are basically C-channels, 15 inches long, 4-inch wings, 3/4 of an inch thick, top and bottom. You'll notice that the bottom one is turned upside down to what you would think it would be. This is so the water can drain out. And also, the bridge sets, the wooden timbers of the bridge sets on this bottom lip. The shorter bridge, the rockside bridge, is a little bit different. It only has a flat plate on the top, and it has the U-channel at the bottom, and the bridge timbers sit on it. It's 42 inches top to bottom, and those plates are about 30 feet long also, so they're pretty massive. I would guess that each section probably is pushing the 15-ton limit that was in place on the railroad coming in. This is what each of the panels looks like. Scattered about every 5 feet along the panel are these stiffeners that stiffen that plate up a little bit. We have the C-channel on top, C-channel on the bottom. This is what the gusset plates look like on nominal dimensions. They are 8, 6, 4, and 2 feet. And the rivets go completely through all the plates as the stacks go up. And in real life, they look like this. You can see the top plates up here. And there's also a set upside down here. You'll notice this is one of the stiffeners. This is a joint between bridge sections where you have two stiffeners who are riveted together. Anybody play with erector sets? This is a little bit more different detailed picture of what the truss system looks like. The gentleman at the bottom of the picture, I don't know if any of you knew Mark Widener. He was an engineer for the Rock and Rail Railroad, and unfortunately we lost him about a year ago to a very aggressive form of brain cancer. But he was our guide that day. Just quite the gentleman. Anyway, you can see that we have the bottom links and these big iron bolts going through, the top links going all the way up back again, the cross beam that goes across and all the various pieces. This is another look at the upper eye links. And yes, that's a dinghy where the train car hit it. The bridge got hit a number of times, shifted loads. The pins in here are 4.5 inches OD, 16 inches long. And the bottom ones are 5 5/16 OD and 16 inches long. And this is a close-up of one. That's taken from the train. Surprisingly, the outside is threaded over here, and that's a big nut that holds it all together. The bridge is built to have quite a bit of movement in it, lateral and up and down, which I find rather interesting. That's probably why it survived when the things get hit. As built, the bridge had an open deck. Sunlight shines through. This is a William Henry Jackson image. You can always tell Jackson's images. You know how? There's always a person in there. He liked to put people in his pictures for scale, which I thought was interesting. By open deck, it means that the spacing between the ties was open. You could look straight through down. And I believe that probably that was a design idea. And the design idea was that when you have high water, the water could run through and around the bridge and wouldn't do any damage. To some degree, that was okay, but to other degrees, it didn't work well. And we're kind of going to jump back and forth here on timelines. In 1888, the third rail was added to the route, making it possible for the bridge to be used for standard gauge equipment. Actually, the bridge was designed for standard gauge equipment. The Santa Fe originally planned to build from Canyon City to Leadville as a standard gauge railroad, but when the Santa Fe leased the Rio Grande during December of 1878, there was a stipulation in the lease that anything that was a natural extension of the Rio Grande had to be built narrow gauge, so they just converted over to narrow gauge. We know that because in the materials yard here at Canyon City, there were piles of standard gauge switches and rail braces and equipment that later on was hauled off and used elsewhere. The narrow gauge was removed in 1911. At that time, when the standard gauge equipment, they began to add additional reinforcement to the bridge because by standards it was kind of lightly constructed by this time. After 10 years, the weight of the locomotives and cars had gotten much heavier. So I suspect they put more timber in the bridge, and I believe that they added a stone pier at that time. That was on the rock side in the middle. Oh, other famous events. 1947, the west end of the bridge caught on fire. The Royal Gorge people noticed it, notified the railroad. The railroad rushed a flat car and a locomotive from Canyon City, borrowed a fire engine, put it up on the flat car, hauled it off, got out to the fire. There was no water in the fire engine. So they had to back up, set up a siphon, fill the tank. They eventually got the water put out. But the end result was the railroad decided to put a ballast deck in to reduce the fire hazard. Basically, they filled in all the spaces on the floor so that it was tight, poured ballast over the top, and then lifted the track up and reballasted back underneath it. It did have an effect, though, that was important, and that is it reduced the dimension between the bottom of the rafter system and the top of the rail. 1879 to 1900, the bridge was hit by a number of different flash floods. And there were large deposits of debris. In one occasion, I didn't bring the picture, but Eve shared it with me. There's a huge mass of material that's piled up on the bridge, and it's actually sprung the bridge out about 2 feet off of center. And you would think, oh, that's the end of it. But the solution was they put a big brace in between the rock wall and the through plate girder, removed all the debris, knocked the brace out, and the bridge popped back where it belonged. I wondered about that. I have a very good friend who is the principal bridge engineer at the Transportation Technology Center in Pueblo. And I asked him, is that unusual? And he said, a good bridge is designed to do that. It will spring back into its shape if it's allowed to. In 1901, they tried a number of things in here. They tried a couple of masonry walls. The river got to each one of them. But in 1901, they finally decided on a final solution. They started by building freeboard walls, which is a naval term. Freeboard is the amount of space from the level of the water to the top of the wall. Starting up the canyon from the bridge, they built a series of masonry and concrete walls raising the side of the right-of-way, and they put that big fancy iron fence on top of it. The rock wall basically gives the river a more direct channel to follow, kind of forces it to go. And at the same time, they built a rock wall, a massive rock wall, underneath the bridge. The rock wall at the bottom is about 6 feet deep, and the center of the wall at the top is directly under the riverside rail. Across the top is what they call a concrete batten, and the bridge sets down on top of that. So in 1901, the bridge came unhung, and it still is unhung. And it looks like this on the inside. Not sure when these concrete piers went in, but I assume after the masonry wall. The reason why is that in 1901, structural concrete wasn't a big thing, and these appear to be somewhat later in issue. And if you look, you can see that these concrete piers staggered along basically are underneath the rock side rail. And on top of these concrete piers are 3 pieces of railroad rail that are being used as I-beams, and they are tucked underneath the deck. And so now the outside rail and the inside rail are now setting on solid foundations. And they are that way today. In order to drain Bigler Gulch, they included a culvert, which you can actually walk through and get out to the riverside. There's a ledge on the riverside. You can walk along. This drains rainwater coming down Bigler Gulch. It also provides an equalization. During high water, water is allowed to back up through that culvert and equalize the pressure on both sides of the walls on the inside. This masonry pier is the one that I think was added about the time the standard gauge was installed. Yes, the bridge gets hit. In 1961, a new tri-level auto rack smacked into the truss system on the rock side. And you can see it did quite a bit of damage. But since the bridge is no longer hanging, the rafter really doesn't serve a great deal of purpose. That's not quite true. Roger Barris, who is currently with the FRA, was the last Rio Grande Bridge engineer. And he says he believes that when a train passes over the bridge actually, the iron part of the bridge carries 10 to 15% of the live load even today. In 1917, the Interstate Commerce Commission called the iron bridge a delightful ornamental iron handrail. What do you do when this happens? You move them up. It happened again in 1986 when a double stack car hit the bridge. So they go in and they build a timber frame underneath the center of the trusses where the center beam is. And because of the way the rock is arranged, you just chip out some of the rock and you swing it up a little bit and then repin it to the wall. Well, they've done that twice now. These are the original holes. This is where they moved them in 61, and this is when they moved them in 1986. I don't know. It's 2 or 3 feet. The limiting factor is not so much the iron bridge, but it's other tunnels on the line. If I remember correctly, the bridge can handle double-stack international containers, but it can't handle double-stack domestic containers. It can handle 1 domestic and 1 international, but not 2. They're too high. They're another extra foot each. And as we said, the bridge has been hit a couple of times. But because of the way the suspension is, I guess it just wiggled around and stayed in place. The only addition to the bridge that we're aware of are these new steel plates at the very top. When they raised the angle on the rock side, it kind of changed the forces that would push the bridge down. So they bolted in these big iron plates along the sockets at the top. And now the bill for the day, and we'll be done. This is the original cost of the bridge. This is taken from the National Archives, and I actually have 2 sources that document it. The National Archives has 3.5 cubic feet of information on the Royal Gorge War, documenting all of the lawsuits that were filed. 99% of it is handwritten court testimony. Beautiful, beautiful script. You can read every word. There are some published judicial decisions that are in little pamphlet formats. C. Taylor Smith's original bid was $16,100. Freight on the material to bring it west was 50 cents per 100 pounds. And then freight on 1 carload of cylinders and 1 carload of tools and lost time. And probably the most unusual part is down here at the bottom. That's this advance. During the 2 years that the Royal Gorge War occurred, inflation ran 25%. And so the court allowed Smith to be paid an extra 25% on his original bid in order to make it fair, I guess. So the total cost, $23,460.74, or in 2019, it was just around $640,000. I calculated it the other day, it's closer to $700 today. And I'm all done. I'll take questions if you like.
Was there ever any idea that they'd have to change? I mean, the bridge wasn't sag.
No.
Reason, so they didn't have any adjustment, turnbuckle or anything to.
No, they didn't. There was no inclusion for that in, but I have to tell you that around 1904, there was serious consideration of building a second main line through on the south side of the river. And it would have bypassed the hanging bridge site with the tunnel. So there are other considerations in there. I'm not sure exactly why they changed their mind and didn't go ahead and build it. They and the city had reached an agreement over the water line that was in construction at the time. Is that the right year, Eve? 4?
It was completed around 1909.
Okay. But there was really strong consideration. You have to realize that up until 1936, all the traffic on the Rio Grande between Denver and Salt Lake City went through Canyon City. This was the main line. There was no Moffett Tunnel. There was no route west. And so the Rio Grande was very protective of this route. When it was down, in the early years there were alternatives. You could use the Colorado Midland from Buena Vista to get to Colorado Springs and bypass the gorge. But after 1920, the Midland was abandoned. So without this line, they were dead in the water. Yes?
Have you thought about writing a book about this? This is wonderful. Yes,
I have. I have so many projects. I helped Doris Osterwald do her book on Rails Through the Gorge when she wrote it. That's been 15, 20 years ago.
and he's trying real hard to keep me honest.
Yeah. I have a historic outline of the Royal Gorge War that's over 300 pages long. And it's in 0.7 font. And that's not including the pictures that I also have collected. And I have to credit Eve for contributing to my photographic collection. But we share stuff back and forth all the time.
It's an obsession.
It is.
Okay, I want to thank Larry for his
Yeah.
coming, and please continue to ask him questions. We are grateful for
Oh,
your
you didn't have to do that.
presentation, and thank you very much. I am passing the hat.
Oh, thank you. I have some business cards. If any of you have questions later on, you can certainly ask or send. I answer my email.